Hi, this is Zachary Gold, and today I'm going to be going through my final project for my Learning Analytics class here at Delphi University. So first things first, I'm going to bring up my discussion post where I go through the background of my project and ask my preliminary questions. So I'm just going to read through this very quickly. Since New York City Mayor Bill de Blasio proposed eliminating the specialized high school admissions test, or the SHSAT, there's been a fiery debate about the test's efficacy in determining the best student candidates, as well as the equity of the test process itself. As an alumnus of Brooklyn Tech, one of New York City's specialized high schools, I'm a member of the Alumni Association, as well as a member on the Brooklyn Tech Alumni Facebook page. There, many of my peers have argued that the SHSAT is the most objective method of determining the best candidates because it is a standardized test. And moving to a more subjective process, such as interviews, GPA review, per-district quotas, race, gender, or economic background, could introduce bias and potentially lower outcomes. Many advocates for the abolition of the SHSAT argue that that teacher-to-student ratios, access to after-school programs, and free test prep courses are the primary predictors of SHSAT performance. As the above factors are primarily determined by the funding a school receives, this project will focus on the causal relationship between school funding and SHSAT performance in an attempt to establish whether there is a causal link. This project will hopefully answer the following questions. To what degree, if any, does school funding influence student success on the SHSAT? And if school funding is a determining factor, can it be causally linked with the underrepresentation of Black and Latinx students in specialized high schools? So I used the following data sets to do my research. So I've got specialized high school admissions data from 2015. All of these data sets are available on data.cityofnewyork.us. So I'm just going to give you a brief overview of what those look like on the platform. So let me pull this one up real quick. This is the SHSAT admissions test. So the way that this data set is broken down is by sending school. So there are a couple of different columns in this data set. Feeder school DVN, that's the district borough number. It also has the name, count of students, total count of students in the admissions, count of testers versus count of offers. And you can see here, it's a little janky because they, if you have 5 or less, it winds up being 0 through 5, which really throws off a lot of the calculations because it means this is a field of strings and not a field of numbers. So I'm going to have to change this value to be something else in order to do numerical calculations on this field. But we'll get to that. So this is the first data set. This is the SHSAT admissions trends, I guess, by sender school. Here I have the demographic snapshot between 2013 and 2018. There is an entry per year for each school. I'm going to be concentrating on the 2015 data because that's the only year that I actually have budget data for. Unfortunately, the New York City Department of Ed doesn't regularly release the Fair Student Funding budget, so the last time it actually was made available was 2015. So here is the demographic snapshot. Gives you a lot of different columns, breaks it down all by grade, all by ethnicity, gives you an idea of what the percentages are, as well as different metrics like the number of students at each school that live at or below the poverty line, and what the total percentage of the student body they are, what the economic need index of that school is. Economic need index is calculated using a formula that isn't entirely public, as with the formula that's used to measure teacher performance in public schools. They give you a piece of it, but not all of it. Moving on, we've got the Fair Student Funding budget. Here is where all of the funding and fiscal breakdowns happen. This is Detail 2, which gives you all of the in-depth calculations based on the register, that is the number of students in the school, and the formula attached. It does come with this handy sort of data dictionary, which can sort of illuminate a lot of these things if you're curious about some of the data that is a little, there's no real descriptions really to really explain what each of these are. A lot of them you can sort of figure out, registered change, that basically means the change of registered students at an institution from, the last year forward. As you can see here, there's a lot of columns here with a lot of financial data. The main things that we want to be considering is here, which is the formula at 100%. These are the totals with everything calculated together. So you can see certain school, this school got a $7,081,416 allocation for fiscal year 2015. So now that you can see my data sets, I'm going to now go and show you my flow. So I've imported those 3 data sets into Tableau Prep. This is where I'm going to do my cleanup and join all of these data sets together so I can start running visualizations. So first things first, I start with the demographic snapshot. So I will show you here everything that I have to do. So on intake, I designate which fields I want to include. I don't really need any of the breakdowns by grade. What I really want are the demographics. So the number, percentage. We're not really looking at students with disabilities here, so we're leaving those fields out. And also I want to take a look at the poverty percentages to see if there's any correlation between poverty percentage and school funding and student performance. Because that'll really inform my second question, which is, if there is a link, does it account for the underrepresentation of minority students or Black and Hispanic students in specialized high schools? So next up, I set up my first filter on this data. So the issue is that there isn't very good standardization in these data sets, even though they're all released by the New York City Department of Education. So for example, in 2 of the 3 data sets, the way that schools are named is by using this field, the DBN, right, which is the district, the borough, and then the number of the school. Unfortunately, one of the data sets only has location. It doesn't have the DBN. So the location actually is shown this way. So what I had to do in order to make all of the in order to standardize so I can actually join indexed on the school was I had to do some fancy regex stuff. So I'm going to show you that very quickly. So I have 3 changes within this step. I filter to only 2015 data because that's the only fiscal year that I have any financial information for. And then these 2 changes are to create the district and the stripped DBN field. So what I do is some basic regex stuff. So basically what I'm doing with this regex is I'm using the regular expression extract nth function. So basically what I do is I give it the field that I want to run this expression on, which is the DBN. I then designate the parameters. So here I'm basically saying that as if it's between 0 and 999, I just want to I'm certain that there's not a 999th district in New York City, but I just want to be sure. So, and this is the final parameter. This says at what position past this delimiter or what segment after it's been split do I want to show? So this is the second segment. So anything that comes after this is going to be in this field. So it's more or less the same thing for the other one, except here it's a 1. And basically that is what allows me to strip the DBN and then also have the district information as well, which is really handy. So now that that's done, I can index my inner joins using the strip DBN. So Here I just removed the DBN field because it's unnecessary now. It's more or less the exact same thing for the 2015-2016 SHSAT data. I split the DBN, and then I remove the DBN, and then I join. So what I do here to join, it's pretty straightforward. I map location to the strip DBN, which then allows me to match all of the schools that have entries in both tables. I don't want any extraneous data, so the only information I want is, where every field has an entry. I don't want any outliers. So you can see here, I've got 63 excluded and 291 excluded from the two different data sets. That's good. I don't want these information, these points of data, because they're not going to have any of the real information that I need. So after that join is done, I remove the DBN inside this now joined set. I then join it with the other data set, and then I run my final cleanup. So first, I'll remove extraneous fields and exclude schools where the count of testers is 0 through 5, because what that does is really skew the information, because I can't run any numerical calculations, because the field becomes a string of a field of strings that I can't do any calculations on. So first I remove, the duplicate fields. In this case, it would be district. I then remove location because it's no longer needed, because I'm using everything based in strip DBN now. I'm going to rename funds allocated. I'm going to rename this label to funds allocated because it's a little bit easier to make sense of. I then removed count of students and admissions because I don't really need that. And, as I said, I'm excluding any entries where count of testers was 0 through 5. So I can't do the same thing where count of offers is 0 through 5, because 296 out of the total of 416 schools had 0 through 5 in their count of offers field. And this is at the suggestion of Matt Karinga to replace 0 through 5 by 0, because in this specific case they are effectively analogous. I then do two other calculated fields. So I want to calculate the funding per student, so that's pretty straightforward. Funds allocated divided by total enrollment by school. So here's the breakdown for that. It's 416 unique values, because all of these, all 416 schools need their funding. Moving on, I then change the type of these two fields, so they're decimal numbers. That way I can run operations in my, and that way I can do this kind of calculation, which, creates a ratio of tested versus offered, which is count of offers divided by count of testers. And as you'll see in my workbook, this is an incredibly important field. This ratio is really what we're trying to figure out. Does funding increase the ratio of, tested versus offered? So that is my flow. I'm going to now move on to my visualizations. So let me just open up Tableau and put it to full screen. So here's my first visualization. It's a basic line graph that breaks down per student funding by school. So on the bottom, we've got all of the different school names. Over here, we've got the different values. So you can see K50 has a $11,604 allocation per student. K313 has a $12,622 allocation per student. So this by itself really doesn't give us a whole lot of insight. It doesn't inform whether or not schools have similar allocations on a per student basis. This is illustrating for sure that it does not work that way. So next is tested versus offered by school. Same basic thing, schools on the bottom, the values on the top. So you can see up here the color coding, count of offers is in yellow, count of testers is in red. So you can see certain schools send a lot of testers but don't necessarily get a whole lot of offers. So for instance, Bay Academy sent 327 testers but only had 107 offers, which is a ratio of 3.2 or of 0.32 or 32%. There's a 32% likelihood if you're a student at this school that if you took the test that you got an offer. And you can see, there you would expect there to be, somewhat normal distribution, but it's not really the case. So moving on, here's that ratio that I was just discussing. So you can see certain schools have extraordinarily high ratios, while other schools have no ratio at all because, they either had 0 through 5 students actually get offers, which in this case is all put just to 0. So you can see, there's huge peaks. So if you go to, 187 in Brooklyn, you have an 86% likelihood if you took the test that you got an offer to one of the specialized high schools. And now I'm going to start combining some of these graphs. So here's the funding line mapped against tested versus offered by school. So you can start to see here there isn't really any it's not illustrating any link between funding and performance on the SHSAT. And if you go across, you can really start to see the real sort of like negligible link that the funding has, right? So a lot of these schools sent 85 people but no offers, and they have an incredibly high, or this school, East Flatbush Community Research, they sent 21 testers, had no offers, and funding per student $13,000. So I'm going to keep going over so you can get an idea of what it looks like in Manhattan and Queens. Even over here, you see almost no real, there's no correlation. That's at least evident from this display. So it becomes a little bit more obvious when I map the tested versus offered ratio by school against funding. So you can see a place like 187, the Christa McAuliffe School, actually has a below average funding per student, but their ratio is incredibly high. And then you look at other schools, K313, funding per student 12,000, and their ratio is 0. So you can really immediately see that there is no link between funding and student performance on the SHSAT. If anything, it sort of illustrates an inverse link if you want to look at it that way, right? The more money that's spent, isn't having any impact at all. At least that's what the data is starting to show. So this really blows my initial hypothesis out of the water. I really believed that funding would map at least some have some relationship to student performance. So then it made me start asking how does this break down by race and demographic. So then I made this chart which plots that same funding line against the different student body demographics across these different schools. So up here you can see the color coding. Green is percentage black, yellow is percentage Hispanic, red is percentage multiple race categories, and blue is the funding per student line. So you can see in schools that have a huge proportion of the student body that are either black or Hispanic, they tend to get more funding. However, this funding doesn't really have an impact in SHSAT performance. And then you look at other schools, perfect example, 187 has a 6% Hispanic population, 0.5% black population, and their funding is lower. But if you remember from the previous visualizations, their ratio was incredibly high. They had an 86% likelihood that if you took that test, you got an offer. So it really goes to show that we're spending all of this money and we're not necessarily seeing much impact. So it's even more shown by percent poverty, and there is the studies have shown there is a strong correlation between standardized test performance and student poverty levels. The more poor students are, the worse they perform on standardized tests. And you can start to see those breakdowns kind of here. However, you look at 187, very high performing school, 61% poverty level. So, it's more of an exception to the rule than anything else. It's an anomalous outlier. However, as someone that actually went to 187, that was my middle school, the majority of the population at that school is Asian, Chinese, Vietnamese, Korean, Laotian, small Burmese population. But beside the point, these are all, these are students from cultural groups that tend to value education at a much higher level than other cultural groups. And this really opens more doors in terms of questions than it answers. Because based on my anecdotal experience going to Christa McAuliffe IS 187, the only reason I went to that school is because my father woke up at 4 o'clock in the morning one day and then waited online for 4 hours to apply for me to get a slot in that school. Which goes to show, at least anecdotally, that there are more factors that are considerably more intangible and harder to quantify that likely have a much higher impact on performance than funding. A perfect example is a family's involvement in the education of the student, which we will never be able to see from this data. So, I feel like these visualizations are a good jumping off point for further studies and further research into how all of these things break down. We can look at teacher performance information, if the DOE would release it, parent engagement, based on how likely parents are at schools to engage in the PTA, how much private money is being contributed to these schools either through family involvement or outside endowments, and what impacts those have. Unfortunately, none of that data is readily available through the Open Data Portal. It likely would have to be gained through a release through the Freedom of Information Act. So yeah, that's my project.